Hi, this is Dr. W. Today we're going to talk about the atomic radius of an element and how it changes relative to that element's position on the periodic table. Now, atoms are really small. It therefore makes sense to use really small units to describe their radii. The picometer is the unit that scientists typically use to describe the length of atomic radii. 1 picometer is equal to 1/trillionth of a meter. Said another way, there are 1 trillion picometers in a meter. That's a lot of picometers, and that's truly tiny. The atomic radius is defined as 1/2 the distance between the nuclei of 2 atoms of the same element placed right next to each other. If we represent that distance with a line, the radius is 1/2 of that line. It is defined like this because it is easier for scientists to find the internuclear distance and then cut it in half than if they just had one atom. Each element has an atomic radius associated with it. Hydrogen, the smallest element, has a radius of 30 picometers. As we move up an atomic number to oxygen and nitrogen, by adding protons, the radius generally increases. Because there are so many elements in the periodic table, it would be really nice if we could find some sort of trend or pattern. We will talk about these trends as we move down a group or column and across a period or row. This graph shows atomic radius as a function of atomic number or number of protons. As we move along the x-axis, we change the atomic number and hence the identity of the elements. We start off with hydrogen and move up from there. On the y-axis, we show the atomic radius in picometers. To show how atomic radius changes as we move down a group or column, I would like to focus in on the elements in yellow. The first element we see is lithium. It is also the first in the alkali metals group on the right. The last in yellow is cesium. It is the second to last of the alkali metals on the right. The graph shows that as we move down a column, atomic radius actually increases. Now, if we focus on elements in the same period, starting at potassium, and ending at krypton, we actually see that the atomic radius tends to decrease as we move across the row. Let's discuss why we see these trends. As we move down a group or column, there are 2 reasons why the radii of the elements increase. The first reason is due to the addition of new energy levels. Lithium, as shown here, has 2 energy levels, while sodium has 3. This makes sodium naturally bigger than lithium. The second effect is due to the shielding of the nuclear charge felt by the outermost electron by the inner electrons. Here, we see that lithium's outermost electron is shielded from the positive charge of the nucleus by only 2 electrons, while sodium has 10 electrons shielding the outermost electron. Because this electron does not feel the nucleus as much, it resides farther away from it, thereby increasing sodium's size. As we move across a period or row, we see a different effect with respect to atomic radius. The atoms actually get smaller. This is due to the increasing number of protons, resulting in a stronger net nuclear charge. Potassium has only 19 protons, while krypton has 36. Each electron in the potassium only feels a nuclear net positive charge of 19. While in krypton, the nuclear charge of 36 keeps the electrons closer to the nucleus. To summarize, atoms tend to get smaller as you go across a period, and they get larger as you go down a group. Thanks for watching. This is Dr. W signing off. Have a great day. If you'd like some more help with chemistry, come visit us at www.phdtutors.net.